Hi all. In this class, we are just going to have what is mean by modulation and what are the different types of modulations out there. Okay, so the modulation is the important process. It's must included in the concept called biotelemetry. Okay, so I think in last class we discussed the basic elements which is being involved in biotelemetry. Okay, you have receiving end, you have transmitting end, you have set of blocks in transmitting end, and you have set of blocks in receiving end. The hot component of the biotelemetry is one is transmitter and the one is receiver. Okay, the thing is we can't transmit the signal. Okay, whatever the signal may be, whether it is a biological signal or non-biological signal, whatever our signal of interest, if you want to transmit, we can't transmit in a just like that. Okay, we can't transmit the signal just like that. We have to do some modification. Okay, so because these signals are usually in low in frequency, it is not good enough to transmit or to cover the long distance. It will not travel over the long distance because of that capacity, because it have very low frequency range. Okay, so this type of signals we have to do some modification. We have to do some modulation process so that the signal now will get strengthened, have the ability to travel over a certain distance. So that one particular technique is called, which is highly employed in the process of biotelemetry, is modulation. So the modulation, as a definition, it is a process of superimposing of low frequency signal on a high frequency carrier signal. Here comes a picture of carrier signals. The carrier signal is like a messenger. Here it acts as a bus. Okay, you know the bus is the like carrier. It will carry all the passengers to travel from one destination to another destination, and it leaves the passenger. Right, that is the purpose of bus. Similarly, here also we have the carrier signal. Here it will act as a bus, like a messenger. This carrier signal slowly it will carry the signal of interest from one place to drop the signal of interest into the another place. Okay, that is the main purpose of the carrier signal. And choosing of the carrier signal also very important. We can't choose a carrier signal just like that without seeing the frequency and amplitude. So while choosing the carrier signal, you have to be very careful. You have to choose the carrier signal frequency. The amplitude should be always higher than your signal of interest, that is your baseband baseband signal. Okay, so in this way you have to choose the carrier signal. This is the main importance of having carrier signals in biotelemetry. Now we will come into what are the different types of modulation we can widely used in case of transmitting biological signal. In the sense, there are basically three modulation. One is amplitude modulation, second one is frequency modulation, and third one is phase modulation. It's the amplitude modulation. So here the two signal is going to play a role. One is carrier signal, another one is signal of your interest, that is the original signal. So here you are going to superimpose these two signals. But how means this carrier signal will get modified in terms of original signal. That the based on the term, we have these three classification. If it is changed according to the amplitude, if it get modulated according to the amplitude of the original signal, then it's called amplitude modulation. Okay, so if the amplitude of the carrier signal is changed in proportion to the message signal, whereas the other phase and frequency of the carrier signals are kept constant, then but that particular modulation is called amplitude modulation. Again, if you take the phase, okay, the next one is what? Phase modulation. Here in this type of modulation, the phase of the carrier signal is altered. Okay, the phase, okay, the carrier signal one phase of the signal is only altered in occurrence in according to the your input signal. So whereas other parameters like frequency, if you keep other parameters like frequency and other amplitude kept constant, if you are changing only the phase of carrier signal according to your input signal, then it is called phase modulation. And last one is the frequency modulation. So in this case, in name itself, you might have guessed it now. In phase modulation, in frequency modulation, here the carrier signal is changed in occurrence to the message signal. Okay, in occurrence to the message signal, while the phase and amplitude are kept constant. So that if you are doing the modulation in this way, just by changing the frequency, then it is a frequency modulation. If you are changing the phase, then it is called phase modulation. If you are changing the amplitude, then it is called amplitude modulation. Whereas whatever you are changing, where you have to keep other two parameters as a constant, so that because of that the naming is like you're having amplitude modulation, you are modulating only amplitude. In phase modulation, you are modulating only phase signal, and last you have frequency modulation, you are changing only the frequency. Okay, so by doing in this way, you are strengthening the incoming signal, so that now it's a good enough to transmit over a certain distance. So that's how this carrier signal is being involved in bioelementary transmission. Here, like as we discussed, we have a three basic modulation. You can use any type of modulation for any applications. Okay, so based on application, the type of choosing modulation will get vary. So okay, so these are the basic introduction about what is the modulation, what is the importance of carrier signal, and how does it act, and what are the different modulation. Everything we discussed in this class. So thank you. So next class we will have a continuation of this biotelemetry in detail.